So in this video we're going to do the exact same thing as we did in video 1, but with a weak base and its conjugate salt. So in this case I'm going to pick this weak base. Okay, so the conjugate salt, well, what does a base do in water? It's going to do this. Right? So this is going to be my conjugate acid. So I'm going to have a salt of some type with that. So the salt I'm going to pick is a chloride. Okay, so there's my salt. And in this problem, I'm going to have a 0.1 molar solution of this, and I'm going to pick a 0.235 molar solution of my salt. So 0.235 molar solution of my salt. So what do salts do? Well, salts break apart 100%. So this thing would do this. So I would be starting with this molarity of that and this molarity of the chloride. I don't care about the chloride, but that's what its molarity is. So when I actually start my ice table, I'm not starting with 0 of this, I'm starting with 0.235 molar of that. Whoops, sorry, that should not be chloride there, that should be OH. My fault. And I'm starting with 0.1 molar of this. So then I do my ice table. I'm going to shift right. 0.100 minus x, 0.235 plus x, and then I will write my equilibrium expression. Kb is equal to this over this. The Kb you have to look up, and it's 1.1 times 10 to the negative 8th. So I've got 0.235 molar up here. I don't know the concentration of OH. Sorry. Back up the truck. This is 0.235 molar plus x. This is x, and on the bottom is 0.1 minus x. I was getting ahead of myself there. Okay, so just like in the last problem, look at our x's. This x is too small. Why? Because the 0.1 and that are off by a factor of 100. This x is too small. Why? For the same reason. This 0.235 molarity is off by a factor of 100 compared to that negative 8th. So that simplifies my problem down to 0.235 times x over 0.1. Now, problem's a heck of a lot simpler. Just putting it into my calculator right now. I get 4.68 times 10 to the negative 9th. And remember, that's the concentration of OH. So I always like to find the POH. So then my POH is 8.32. And so my pH is 5.67. Let me check my calculation here for a second. Yep, that's right. So that's my pH for the solution. That's how you go about doing a weak base and a weak base buffer. Okay. The third video will be a little bit longer, so just a warning.